Alright, so this is part 2 of the 11.3 notes. On the previous example, I focused on parallelograms. For this video, I'm going to focus on the last 3 shapes, rhombi, rectangles, and squares. So all the examples we're going to see today are going to be for either one of these shapes. And again, for the examples, I will not be working them out entirely. I will only help you determine which property you're using and set up your equation based on that property. So on this video, we're going to look at 6 examples. So for example 5, I have a rhombus. I know it's a rhombus because it looks like a parallelogram, but it has all sides that are equal. So I'm gonna mark all my sides as equal, and I'm gonna label the information that's given to me. This is a rhombus. So I'm filling this. The name is a rhombus. So they gave me AD, which is 9x minus 14. So that's a side length. From A to D is 9x minus 14. And then they gave me side length AB. So AB is this top side right here. That one is 3x plus 37. And then they're asking me to find BC. So BC is this part. That's what they're wanting me to find. So for this one, the information that's given to me is about sides. I marked sides. I'm going to circle sides. And so in my notes, I'm looking at the box that is for a rhombus. So here it is. And I'm looking for information about sides. So the only thing that I wrote here is that about sides is that all sides are congruent. So that has to be the property that I use. All sides are congruent because they're giving me information about the sides. So all sides are congruent. Remember, congruent means equal, so then I'm going to take those two expressions and I'm going to put them equal to each other to solve this problem. So it's going to be 9x minus 14 equals 3x plus 37. And so this is the equation you would solve. Once you have x, you will plug it in for BC, even though they don't give you a side for BC. Doesn't matter, because remember, they're all equal, so it doesn't matter where you plug it in, you'll get the same answer. Okay, so example 6, they're giving me measurement of angle AXD. So here, AXD is this one. I start from A, move to X, and then D. So they're giving me this angle. And again, this is a rhombus. So I'm going to be looking at information about angles for a rhombus. So here's my rhombus. So first one talks about sides. I don't need sides, I need angles. Next one talks about diagonals. Diagonals are perpendicular, they're equal to 90. Perpendicular means they intersect at 90-degree angles. So even though it doesn't say angles in the notes, the diagonals create an angle that's 90 degrees. So these angles right here in the center, those are 90 degrees, they're right angles. Perpendicular means they intersect at 90 degrees. So this right here, I can put a little square, meaning that it's a right angle. That's 16x minus 10. So the property that I'm using here, really, you could say it's angles, say it's diagonals, because it's pretty much an angle that's created with the diagonals. So the property I'm using is diagonals are perpendicular. Which means they intersect at 90-degree angles. So I'm going to take that expression, 16x minus 10, and I'm going to put it equal to 90. and that will give you your x value. Okay, one more example with the rhombus. So this is example 7, still a rhombus. Here I have measurement of angle DAC. DAC, DAC, so it's that angle right there. That's 10x plus 11. And then they're giving me BAC. That's BAC. It's that angle right there. 5x plus 16. Okay, so again, information that's given to me is about angles. So I'm going to look at my notes for angles. And so here it is again. So I'm not talking about sides. I'm not talking about diagonals being perpendicular. Diagonals bisect opposite angles. So this is another information about angles. What this means is that the diagonals in my rhombus will cut each of the angles into 2 equal parts. Bisect means to cut into 2 equal parts. So then in my example, the diagonal AC is cutting angle A into 2 equal parts. So really those 2 angles are equal. So I could put 2 lines to show that they're equal. So the property that I'm using here is diagonals bisect opposite angles. And so that means they're equal to each other. I'm going to put those 2 equal. 10x plus 11 equals 5x plus 60. And then you would solve this equation to get x. Okay, 3 more, just setting them up. Example 8. So now we're looking at rectangles. Now we're moving on to rectangles. So example 8 and 9, both of them are rectangles. So the name rectangle. I know because it has 4 right angles, so it's a rectangle. For this one, they're giving me the measurement of the angle DAC. So where is that? That's DAC. So that angle. And they're also giving me the measurement of angle BAC. So similar to the previous example that I just set up the equation for, but in this one's a rectangle, so it has to be a different property. For this one, if we look at rectangles, information about the angles of a rectangle, you can see that it has 4 right angles, so each of those corners are 90 degrees. So that's the property I'm using, 4 right angles. And so that means that angle A should equal 90 degrees. So if you look at the picture, the blue angle with the pink angle, if you put them together, they're creating a 90-degree angle. That means that when you add them, it should equal 90. So to be able to solve this problem, that's what I'm going to do. I'm going to add those 2 angles, and I'm going to put them equal to 90. I'll have 18x minus 10 plus 12x plus 40 equals 90. Example 9. Again, a rectangle, but this time they're giving me different information. They're not giving me angles, they're giving me lines, AC. So here's line AC, all that line. That line is 16x minus 30. And then the other one, BD, that one is 2x plus 12. BD. Oh, that line BD, that's 2x plus 12. Okay. So this time they're not giving me angles, they're not giving me sides. Those are the diagonals because they're inside of my shape. So diagonals. And so the property that I'm looking for has to talk about diagonals. So for rectangles, diagonals are congruent. That's the property I'm using. And so again, congruent means that they are equal. So I'm going to put those two expressions equal to each other. I'm going to have 2x plus 12 equals 16x minus 30. And then you would solve that equation, get x, and then plug it in for AC. Alright, and so last example is example 10, which is now a square. So on this one, I'm looking at every single rule that I've written down in my notes because all the properties apply to squares. So I'm going to label my picture first. So for this one, they gave me AC, which is those. And then BD, which is this. So again, they're giving me the diagonals. So I'm looking for information about diagonals. And if you notice, it's very similar to the rectangle. They gave me those two diagonals inside. And because the rules for a rectangle also apply to the square, then I can do the same thing. Diagonals are congruent. So that's the property that I'm using here. So this is for a square. So exact same thing I did over here. I'm just going to do it with these expressions. 15x minus 70 equals 3x minus 4. And then you would solve for x, get x by itself, and then plug it in for BD because they're asking you for BD.